Hello and welcome to the 8th clinic in linear algebra. In today's clinic, we're going to look at the definition of a determinant. Right? And then we'll see a shortcut for evaluating determinants of 2x2 and 3x3 matrices. And so the definition of determinant is rather technical, right? So just go ahead and view the video in linear algebra playlist for the definition of a determinant to see the technical definition. For 2x2, the definition of the determinant boils down to this. A11 times A22 minus A12 times A21, right? So if we look at it, it's essentially going to be this. Right? You take that product and then minus that product. So whenever you go to diagonally to the right, the term is positive. Whenever you go diagonally to the left, the term is negative. Right, so determinant, we can write it this way. So right out the matrix, but now instead of brackets, we just put the vertical bars. So we get 6 times 3. Right, now we're going the other way, so minus 5 times 2. 18 minus 10, we get a determinant of 8. Okay. All right, so for this determinant, it's going to be 2 times 7 minus negative 3 times 4, right? So 14 minus negative 12. This determinant is 26, right? So notice the determinant of a matrix is a constant. Right, so the determinant is a function, a mapping from the set of square matrices to the real numbers. Okay. So looking here, I'm actually going to go full screen. There we go. Four times negative 2 minus negative 5 times negative 1, right? So we're going to get negative 8 minus 5, and our determinant this time is negative 13. Right, this determinant will get t minus 5 times t plus 2 minus 6 times 3. All right, we do that FOIL. We get t squared minus 3t minus 10, and then minus 18, right? And so we get as our determinant this time, t squared minus 3t minus 28. Now we look at 3 by 3. Definition for the determinant of a 3 by 3 is going to boil down to this. A11 times A22 times A33 plus A12 times A23 times A31 plus A13 times A21 times A32, right? Then minus A13. Let's do this. A11 times A23 times A32 minus A12 times A21 times A33, and then minus, let me move it down to the next line, minus A13 times A22 times A31. Right, so if you look, I'm going to do all the positive terms, right? So A11, A22, A33, that's that. A12, A23, A31 goes like this. A13, A21, A32 goes like this. Right? Right, going with the negatives, we go A11, A23, A32, A12, A21, A33, and then A13, A22, A31. So again, right to left is positive. I'm sorry, left to right is positive, right to left is negative. And you cannot extend this crossing method, right, to anything above 3 by 3. We're going to have 2 times 4 times 1 plus 3 times 3 times 1 plus 4 times 5 times 2, then minus 2 times 3 times 2 minus 3 times 5 times 1 minus 4 times 4 times 1. Yeah? So we get what? We get 8 plus 9 plus 40 minus 12 minus 15 minus 16. And this will give us a determinant of 14. Okay, so this determinant, 1 times 4 times -2 plus -2 times -1 times 1 plus 3 times 2 times 5 minus 1 times -1 times 5 minus -2 times 2 times -2, and then minus 3 times 4 times 1. 8 plus 2 plus 30 minus -5 minus 8 minus 12. So we get a determinant of 9. Okay. Get 1 times -1 times 1 plus 3 times 2 times 1 plus -5 times 3 times -2, right? Then minus 1 times 2 times -2 minus 3 times 3 times 1 minus -5 times -1 times 1. -1 plus 6 plus 30 minus -4 minus 9 minus 5. And this gives us a determinant of 25. So that is how we can find determinants of 2x2 and 3x3 matrices. So that will do it for today's clinic. In the next clinic, we are going to begin to look at methods of evaluating determinants for higher order square matrices, right? So 4x4, 5x5, so on and so forth. The first method that we will consider is looking at triangular matrices. So trying to get the matrix into triangular form to take the determinant. I will see you all then.